will begin the final part of the chapter, physical quantities and measurements, and that is about flotation and floating and sinking. Now, as you have seen, you must have seen it in your daily experience that when you put a iron ball or something very heavy, a stone suppose, in water, it sinks. Whereas if you put a light object like suppose a feather or a small piece of paper or things like that, those bodies float in water. Now, what causes a body to either float or sink in water? Now, the general rule is that when the density of the solid is greater than the density of the liquid in which you are putting the solid, if the density of the solid is greater than the density of the liquid, then the solid will sink in water or in the liquid. Whereas if the density of the liquid is greater than the density of the solid which you are putting, then the solid will float. And so this is the general rule, this is the general principle that floating follows. Now, to understand this a little better, we will do the principle of flotation. Now, what happens when we put certain body in water? Suppose this is a fluid in a vessel and we have immersed a body in this. What are the forces acting on this body? Number one, the first force which comes into play is the weight of the body which is acting in the vertically downward direction. This is the weight of the body. Along with the weight of the body, there is another force which acts on the body, which is known as a buoyant force. This buoyant force actually pushes the body upwards. It is an upward force. So there is also another force which is known as the buoyant force, and this buoyant force acts in the upward direction. This is FB or buoyant force. The value of this buoyant force is equal to the weight of the water displaced by this immersed solid. So this buoyant force is equal to the weight of the water which has been displaced by this solid. When you immerse a solid in water, obviously it will displace some amount of solid, some amount of liquid or water. Whatever the weight of the displaced water is, that is the value of this buoyant force. And because this is a force in the upward direction, it tries to push the body upwards. So this is also known as upthrust. Now there can be three cases. Number one, the weight which acts in the downward direction can be greater than the upthrust or the buoyant force. If the weight is greater than upthrust, the body will sink down. So what will it look like? It will look like this. The weight is acting downwards, the upthrust is acting upwards, and the body has sunk down in the liquid. This is case number one. There can be another case. There can be two more cases. The next case can be weight is equal to upthrust. What will happen in that case? In that case, the solid will immerse itself just below the surface of the liquid. So it will just remain below the surface of the liquid. Again, the weight is acting in the downward direction and the upthrust is acting in the upward direction. This is when the weight equals the upthrust of the body. Next, another case, the last final case is when weight is less than upthrust. When weight of the body is less than upthrust of the body. So you see in this case, the net upward force, which is the upthrust, that is greater than weight. So obviously the body will float up because the net downward force is smaller. So in that case, the body will float in water. It will partially float in water. And how much portion of it will be immersed in water and how much portion of it will be out of water will be determined by the fact that only that amount of the solid will be immersed in water so that the weight of the liquid displaced by the immersed part balances the weight of the entire body. That is, we have to make sure that the upthrust is greater than the weight. So how the arrangement will be is the body will float in such a way that the part which is immersed inside the water displaces so much quantity of water so that the weight of the displaced water equals the weight of the body. That is the condition of floating. Fine. And in that case, when the body floats, the apparent weight of the body will be 0. It will appear as if the weight of the body is 0. So these are the three conditions. When the weight is greater than the upthrust, the body sinks down. When weight is equal to upthrust or the buoyant force, the body floats with just below the surface of the water. And when weight is less than upthrust, the body will partially float in water with so much amount of the solid inside the water so that the weight of the displaced water equals the weight of the body. So these are the three cases. Now comes the principle of flotation. The principle of flotation we already did. Now comes the law of flotation. The law of flotation says exactly the same thing as I have discussed, as I said just now, that when a body floats in water, the part immersed in water is such that the weight of the liquid displaced by the immersed part equals the weight of the entire body. Clear? You will find the statement in the book also. This is the explanation. Now, there are many applications of floating and sinking that you have seen, that we can see around us, and is of great importance. Number one is an iron nail. If you take a small iron nail and you immerse it in water, you will see that it sinks in water. But a ship which is made up of iron, that floats in water. So how is that possible? Why does an iron nail sink in water but an iron ship floats in water? You see, the iron nail is solid. That is, it is entirely made up of iron. There is no hollow inside. It is solid iron. Okay. But a ship is made in such a way that a large part of the ship inside is hollow. So even though the density of iron is greater than density of water, so obviously the iron nail sinks in water. But in case of iron ship, what happens is the average density of the iron ship is less than water. Why is the average density less than water? Because the volume is so large and it is hollow from inside. So the volume is so large that the average density of water becomes less. Average density of the iron ship becomes less, and it becomes lesser than water, and therefore it floats in water. So that is how iron ship floats in water. Similarly, you will see that ice sinks. So ice is also an exception in case of density of solids and liquids. Usually solids have higher density than liquids. But in case of ice, what happens is the density of ice is actually less than density of water. Ice is a solid form of water. So even though it is solid, its density is less than liquid. So ice, the density of ice is near about 0.9 gram per cc, but the density of water is 1 gram per cc. Therefore, ice is less dense than water, and ice floats in such a way that 9/10 of its volume is beneath water. So why is that so? That is because when 9/10 of the ice is beneath water, it displaces such an amount of water so that the weight of the displaced water becomes equal to the weight of the ice, and therefore the ice can float. According to the law of flotation, the ice can float. The same thing happens in case of icebergs. Icebergs look very small when you see them from the top, see them from the surface of the sea. But actually inside they are huge. There is a huge quantity of ice beneath the surface of water, because of which it becomes very dangerous for ships to navigate around icebergs, because they can't see what amount of ice is beneath the surface. So that is how ice floats in water. Next is submarines. Submarines is another example. Submarine is nothing but a kind of a, you know what submarines are. It is a kind of a closed ship or a closed boat which can either go down or rise up in water according to its according to the will of the whoever is driving the submarine. So how that happens is, submarine has got water tanks in it. Now when it wants to rise up to the surface of water, what it does is that it releases its water tanks. All the water is eliminated out. So what happens? The average density of the ice of the submarine then becomes smaller. That is how it rises up. Again, if it wants to sink down, it fills up all the water tanks. Its average density becomes more and it sinks down. This is how iceberg works. This is how submarine works. And there is also the example of whales. Whales, they have got swim bladders. In the same way, when the whales are below the surface of the water and they want to rise up to the surface, they fill up their swim bladders with air. Now as they are filled with air, what happens? The volume increases, the average density of the whale decreases. And that is how it can float up to the surface. Again, if it wants to sink down, it eliminates the air from its swim bladder and it can again sink down. So this is how flotation and sinking works. So with this we come to the end of this chapter, physical quantities and measurements. You go through all the videos and see if you have any doubts. We can clarify them later on in the online class also. So thank you. We'll end the chapter here.